This is Rosen, Discrete Mathematics and its Application, Section 2.6 on matrices. Here we discuss matrix multiplication. If I have two matrices, A and B, and their dimensions are m by k, that is the number m rows and k columns for A, and k rows and n columns for B, then I define the product of A and B, and I denote it A on the left side, B on the right side, is an m by n matrix that has the ijth element equal to the sum of products of corresponding elements from the ith row of A and the jth column of B. Okay, and we'll see an illustration of this with on the next slide, but let's do an example first. All right, we're going to take two matrices and multiply them together. And first, let's check their dimensions. Remember, rows always comes first in the dimension description, so it's going to be a 4 by 3 matrix on the left and a 3 by 2 matrix on the right. In order to multiply them, we have to have the same number of columns on the left as rows on the right. Call that the interior dimension. It matches, so we get a check mark there. Then we check the exterior dimensions, 4 by 4 and 2, so the resulting product matrix will have a dimension of 4 by 2. And now let's take a look at that product matrix. And it indeed is 4 by 2. How do we calculate these elements? Let's look at this 14 here. Since it is in the 1, 1 position, it is the sum of products taken from the first row of the left matrix and the first column of the right matrix. If we take the sum of products of those, you'll see that it equals 14. 1 times 2 plus 0 times 1 plus 4 times 3, and so forth. And if we want to calculate this bottom right one here, that's going to be the fourth row on the left matrix and the second column on the right matrix. And we can see that 0 times 4 plus 1 times 2 plus 2 times 0 is equal to 2. And keep in mind that the product of two matrices is undefined when the interior dimensions, the columns on the left matrix and the rows on the right matrix, do not equal each other. All right. More generally, matrix multiplication of A and B looks like this, where I have an M by K matrix on the left and a K by N matrix on the right. My interior dimensions match, and I end up getting an M by N matrix, and that the ijth element of the product matrix is the sum of products of the ith row and the jth column of the first and left and right matrix respectively, which gives us this equation here. It's important to remember that matrix multiplication is not commutative. Just as an example of this non-property, here we have matrix A and matrix B. They're both 2 by 2. The question is AB equal to BA? Well, both of those product matrices will be 2 by 2. I will let the listeners calculate them, but here are the results of those products, and you can see that AB and BA are not equal. So in general, matrix multiplication does not commute. Very important to remember that. Two other concepts related to matrix multiplication. One is the identity matrix. The identity matrix of order n is an n by n matrix where there are ones along the diagonal and zeros everywhere else. So you can see that that's ones along the diagonal there. And the identity matrix has the property that whenever it is multiplied on the left side or the right side of any matrix, you get that matrix back, as long as the interior dimensions match. And finally, we can, if we're dealing with square matrices, we can have the concept of powers of square matrices. So that since you have an n by n matrix multiplied by itself will give another n by n matrix, we can think of a matrix to the 0 power, that is n by n, as being the identity of order n. And then that the square matrix raised to the r power is just A multiplied by itself r times. And there are your concepts of matrix multiplication.